So we completed metathesis of two alkene. Then self metathesis means the two alkenes are same alkene. Cross metathesis means metathesis between two different alkene. Then ring opening metathesis, ring closure metathesis. Okay. Then next one, enine metathesis. Enine metathesis. Enine metathesis means you have to take an alkene, then an alkyne, ene and ine, in the presence of the catalyst. What are the popular catalysts? Schrock catalyst, or you can use Krebs catalyst. Schrock catalyst or Krebs. Krebs first generation, Krebs second generation, Hoida Krebs, etc. Okay. So please listen. In enine metathesis, an example, first example, you have to take an alkene, this is R1, R2, plus an alkyne, this is R3, and it is R4, with a Krebs catalyst. What's the reaction? Breaking of double bond. This is 1, 2, 3, 4. Here a double bond is there, here a triple bond is there. The double bond between 1 and 2 will breaks. Here also the double bond between 1 and 2 breaks, but the third bond does not undergo cleavage. Only double bond breaks. Between 1 and 2, double bond undergo cleavage. Between 3 and 4, double bond undergo cleavage. Then a new bond formed between 1 and 3, 2 and 4. New double bond formed between 1 and 3. So here double bond, this is R2, this is R4. One of the bond is still remaining. Then a new double bond formed between 2 and 4. Between 2 and 4, a new double bond formed. Here an R1 is present and here an R3 is present. So that will be your product. Here there is no elimination of ethylene. First double bond cut. Here double bond, but one triple bond, one of the bond is still remaining. Okay, so that will be your product. Then next example, example 2. So here enine metathesis means that one alkene and an alkyne. Okay, example 2. Here an alkene, double bond, and an alkyne, triple bond with a Schrock catalyst. What will be the product? Double bond 1, 2, this is 3, this is 4. Cut the double bond. Okay, then what happens? Between 1 and 3, a new double bond will be formed. Between 1 and 3, this is 1, this is 3. Between 1 and 3, a new double bond will be formed. Then 3 is connected to 4, one single bond is still remaining because third bond does not undergo cleavage. Then 4 and 2 makes, this is 4 and 2 makes a new double bond. So that will be your product. Clear? 1 and 2, a new pi bond. 1 and 3. Then 2 and 4, a new pi bond. Between 3 and 4, one single bond is still remaining. Okay. Third example. Double bond, triple bond with the Krebs second generation catalyst. What will be the product? Here between 1 and 2 a double bond is there. Between 3 and 4 a double bond is there. Cut. Double bond undergo cleavage. So what will be the product? Between 2 and 3 a new double bond. A new double bond between 2 and 3. Okay. Here NHAC. Here COOET. Then 3 is connected to 4. This is 1, this is 2, this is 3. 3 is connected to 4 with a double bond. 4 and 1 make a new double bond. So that will be your final product. Clear? So this type of question is, or this type of reaction is called E9 metathesis. Here there is no elimination of product. No elimination of product. Then fourth question. Fourth example. An alkene, here a methyl group, here a triple bond Me, here an oxygen, here a double bond, another alkene. Okay, so with the Grubbs second generation catalyst, what happens? What happens? Here two alkenes are there and one alkyne is there. What happens? In the first case, one of the alkene and alkane, these two are neighboring. These two are neighboring and alkynes are more reactive than alkene. So these two undergo metathesis. These two undergo metathesis. 3, 4. What happens? The double bond between 1 and 2 breaks. Double bond between 3 and 4 breaks. So your product will be 1, 2, 3, 4, 5. A 5-membered ring will be your product. So what happens? A 5-membered ring. Okay. Give the same number 1, 2, 3, 4, 5. A 5-membered ring. Okay. Between 1 and 5 a double bond. Then this 5 is connected to 4 with a single bond. Then 4 and 1 makes a new double bond. This is 4, 1, and this fourth carbon containing a methyl group. Fourth carbon containing a methyl group. Is it correct? 1, 2, 3, 4, 5. A 5-membered ring is formed. Between 1 and 5 a new double bond. Between this 5 is connected to 4 with a single bond. 4 will make a double bond with this one. 2 number systems are there. And fourth carbon containing a methyl group. Then this 4 is connected to an oxygen. 4 is connected to an oxygen. C double bond O. Then another double bond. Another double bond. What happens in the next step? Alkene, olefin metathesis. First step is E9 metathesis. Then an enene metathesis. This is 1, 4. For example, this is 5, 6. Double bond breaks. Double bond breaks. Then between these two, a new ring is formed. Give a new number system. For example, 1, 2, 3, 4, 5, 6. So there a 6-membered ring will be formed. Is it? A 6-membered ring will be formed. Yes, absolutely. So already a 5-membered ring is present. And here a 6-membered ring is formed. Okay. So giving the number, this is 1, 2, 3. In the fourth position an oxygen is there. 5 is connected to a C double bond O. Between 6 and 1 a double bond. This First one containing a methyl group. First one containing a methyl group. Okay, so that will be your final product. And already here between these two a double bond is there. These two a double bond is there. Any other? Nothing. Any other substituent? At this fourth carbon a methyl group is there. Okay, this carbon a methyl group is there. So absolutely that will be your final product. First step, aniline metathesis followed by aniline metathesis. Okay, then write the next question. Question number 5. Next question, 5th question, a previous year question, double bond, here a triple bond, here COO C2H5, COO C2H5, two substituents are there. Above the arrow, Ru double bond PH PCy3 PCy3 with 2 chlorine. Then a product A will be formed. Identify A. That is the question. Identify A. What is the product A? What is this? Ruthenium based catalyst. Ruthenium based catalyst. It's a Krebs catalyst. Krebs first generation catalyst. Okay. So what will be your product? What will be your product? Metathesis. Here a double bond is there. This is 1, this is 2, this is 3, this is 4. Break the double bond, break the double bond. Then what happens? Krebs or shock, nothing is mentioned, only a catalyst is given. You have to identify that is a metathesis catalyst. So your product will be between 2 and 4, a newly double bond will be formed. Okay, at this carbon COO C2H5, here also COO C2H5. This 4 is connected to 5. This is 2, 4. 4 is connected to 5 by a single bond. And between 5 and 1, a new double bond. So that will be your final product. So that's a nice question. Okay, then next question, please write a homework. Homework. Krebs. First, the next second question. Double bond. This is R1. This is R2. Here it is triple bond. This is R3. R3. With the Schrock catalyst. SSCH Schrock catalyst. Then identify the product. Then our next discussion, 3 important reagents. 3 important organometallic reagent. First one, Tebbe's reagent. Tebbe's reagent. Second one, Krebs reagent. Krebs reagent. Third one, Metathesis reagent. All of them have same function. Okay, Tebbe's reagent, Grubbs reagent, Pettasis reagent. Your Tebbe's reagent is Cp2 titanium. All these are titanium based reagent. Okay, Schrock carbene. Okay, all Tebbe's reagent, Grubbs reagent, Pettasis reagent, all are Schrock carbene. Cp2 Ti titanium based, CH2 aluminium, chlorine, CH2 chlorine, here aluminium, methyl. This is called Tebbe's reagent, first one. Second one, Grubbs reagent. Grubbs reagent is Cp2 titanium, here CH2, here also CH2, then here an isopropyl group and a methyl group. This is called second one, Grubbs reagent. Third one, Pettasis reagent, Cp2 Ti 2-methyl group, dimethyl titanosine, that is called Pettasis reagent. So familiarize these three reagents in organometallic chemistry. We will discuss many catalysts, reagent or catalyst, Tebbe's catalyst, Grubbs and Pettasis. Function, all the three catalysts have same function. Tebbe's reagent, its modification is Grubbs reagent, its latest modification is Pettasis reagent. Clear? Okay, so copy the structures and the active form of all these catalysts. Active form of all these catalysts is Cp2 Ti double bond CH2. This is the active catalyst. This is the basic structure of catalyst. That catalyst will convert into the active catalyst during the reaction. This is the active catalyst and this is a 16 electron complex. You know all catalytic species are 16 electron species. Okay, so your active form of Grubbs or Tebbe's or Pettasis catalyst is Cp2 Ti double bond CH2. Sometimes this is directly given in the question paper. Cp2 Ti double bond CH2, which is a 16 electron complex, that is the active form of the catalyst. Clear? Okay, so starting our discussion from the very first one, Tebbe's reagent. Function of all these catalysts same. Tebbe's reagent. What is the structure of Tebbe's reagent? Titanium based catalyst, Cp2, Cp cyclopentadienyl, titanium, CH2, chlorine, here aluminium, methyl, and active form of this catalyst. Cp2 Ti double bond CH2. That is the active form of this catalyst, which is a 16 electron complex. Then what will be the preparation? How you can prepare this catalyst? Preparation: titanium tetrachloride, not titanium tetrachloride, TiCp twice Cl2. Titanium Cp twice Cl2 on reaction with Al2Me6 or AlMe3. In some textbook AlMe3 is there, but AlMe3 exists as its dimer Al2Me6. So titanium Cp2 TiCl2 on reaction with Al2Me6, this catalyst will be formed. So this is the reagent. So instead of the catalyst, sometimes these two reagents are given. Instead of this catalyst, sometimes in question paper, the active form of the catalyst is given, Cp2Ti double bond CH2, or the catalyst may be directly given, or condition for formation, Ti Cp CpCl plus Al2 Me6 or Al2 Me, then that Tebbe's reagent will be formed. Our important area is what is the function of Tebbe's reagent or Grubbs reagent or Pettasis reagent. All reagents have a same function. That means, please listen. You know about Wittig reaction. In organic chemistry, we discussed about Wittig reaction. Okay, you know how to write the product of a Wittig reaction. In the case of Wittig reaction, an aldehyde or a ketone, the reactant is an aldehyde or a ketone. Okay, when R is equal to hydrogen, it is a ketone. So aldehyde or ketone, only aldehyde or ketone on reaction with the phosphonium ylide, PPH3 double bond CH2. Phosphonium ylide. How we can write the product? Cut and paste it. Double bond cut. This is cut. Then paste it into here. R double bond. This CH2 is pasted here. So an alkene will be your product. Your product will be an alkene. This is called Wittig reaction. Our Tebbe's reagent, Grubbs reagent, Pettasis reagent, same function, but instead of aldehyde and ketone, they will react further more functionalities. Same reaction, but for ester, okay, for amide is reacted, for lactone is reacted, thioester is reacted. So a wide functionality, same reaction. So your Pettasis or Tebbe's or Grubbs reagent will react with aldehyde ketone instead of ester, amide, lactone, thioester, etc. So please listen. Tebbe's reagent. Okay. So please listen. The reactant species are an aldehyde, RC double bond OH, an aldehyde. Then ketone, RC double bond OR, ketone will react. Then RC double bond OR, ester will react. And RC double bond O NH2, amide will react. Then also thioester, then lactone, etc. Okay, thioester, lactone, etc. But most important functionality is aldehyde, ketone. Our exam point of view, these four are important: aldehyde, ketone, ester, amide. All these functionalities are reacted by Tebbe's reagent. And you know the order of reactivity: aldehyde more reactive than ketone, more reactive than ester, more reactive than amide. Okay, aldehyde is more reactive than ketone. In organic chemistry reagent section, the electrophilicity order of all reagents that we discussed. Aldehyde more reactive. Okay, so then reaction. Please listen. An aldehyde is given RC double or ketone, aldehyde or ketone, RC double bond O R on reaction with the Tebbe's reagent. What is the active form of Tebbe's reagent? Cp2Ti double bond CH2. Cp2Ti double bond CH2. How we can write the product? Reaction similar to Wittig reaction. Cut. Then this CH2 is pasted here. The CH2 is pasted here. So RC double bond CH2R. So that will be your product. So this is the active form of Tebbe's reagent. Pettasis is same. Grubbs reagent is same. So similar reactions are that of Wittig. So a ketone will be converted into an alkene. So you can use aldehyde, Ketone ester also same reaction. For example, an ester RC double bond OR on reaction with CP2 Ti double bond CH2. How you can write the product? Cut and paste. Cut and paste. So RC double bond CH2 OR will be your product. Ester also same reaction. Okay. So this is the function of Tebbe's reagent. Aldehyde will be reacted. Aldehyde will be reacted. Then next one, ketone will be reacted. Ester will be reacted. Amide will be reacted. But write a note. Write a note. Write a note. First one, basic medium is required. Basic medium is required for Tebbe's reagent. Basic medium is required for Tebbe's reagent. Second one, RC double bond OCl and strained system. For example, a strained lactone. A strained lactone. For example, this is a 4-membered strained lactone. This type of system not reacted. So note these 2 points. Basic medium is required for Tebbe's reagent and also acid chloride or strained lactone. Normally lactone will react, but 4-membered such a strained lactone will not react. Okay. Then another question. For example, an aldehyde RC double bond OH on reaction with CP2 Ti double bond, instead of CH2 Cr2 is used. Instead of CH2 Cr2, hydrogen is replaced by 2 alkyl group. Basically Tebbe's reagent, all these reagents are Schork carbene. Here also how you can write the product? Cut and paste. So R, C, here double bond C, R hydrogen. This will be the product. This double bond Cr2 is pasted here. Okay. So in this way also you can expect a question. Clear? So write some worked out examples in standard textbook. First question. All these questions are given in B.D. Gupta. Double bond O, C double bond O, OET, with Tebbe's reagent, in bracket 1 equivalent. Tebbe's reagent 1 equivalent. What is the normal active form of Tebbe's reagent? CP2 Ti double bond CH2. This is the active form of Tebbe's reagent. How you can write the product? Here an ester is there. This is an ester and this is a ketone, which is more reactive. Ester or ketone, which is more reactive? Aldehyde most reactive. Aldehyde, ketone, ester, amide. That is the order. So definitely ketone will be reacted. How you can write the product? How you can write the product? Ester functionality not reacted. Ester not reacted. Here cut and paste. This become double bond CH2. That will be the product. Clear? Next question. Next question. I worked out example in organic chemistry named reaction by G. Jackley. OME with Tebbe's reagent. With Tebbe's reagent, what will be the product? You know, this is an ester, cyclic ester or lactone, C double bond O. Ester will react with the Tebbe's reagent. The active form of Tebbe's reagent is Tp2Ti double bond CH2. How we can write the product? Cut and paste. The CH2 is pasted here. So your product will be O. Okay, here double bond CH2 is formed. Here an OMe as such. Here an OMe as such. OMe. So that will be your final product. So that is called as Tebbe's reagent. Then second catalyst, Grubbs catalyst. Grubbs catalyst structure Cp2 Ti CH2 here a carbon with an isopropyl group and a methyl group. This is called Grubbs catalyst, a modification of Tebbe's reagent. Cp2 Ti CH2 IPR methyl. This is a four-membered ring. What is the active form of this catalyst? Here also active form is Cp2 Ti double bond CH2. That is the active form. Okay. Some first one, preparation. How you can prepare? Preparation is Cp2 Ti double bond CH2 on reaction with double bond isopropyl and methyl group. Then this will be formed. Okay, Cp2 Ti double bond CH2 with CH2 double bond CH IPR methyl. That's a preparation. Function same. What is the function? Similar reaction as that of Tebbe's reagent. Then here some important point. First point, basic medium not required. Then second point, acid chloride and strained system will also react with Grubbs catalyst. So when an aldehyde or ketone or ester or amide with the Grubbs catalyst, the product will be similar to the Tebbe's reagent. Okay. Then the third one, Pettasis reagent. Third reagent is Pettasis reagent. So what is Pettasis reagent? Cp2 Ti methyl. Okay, dimethyl titanosin is called Pettasis reagent. Preparation. Its preparation is very important. Cp2 titanium with 2 chlorine. On reaction with Grignard reagent RMgX, or you can use alkyl lithium Mg plus R minus lithium plus R minus. Okay, you know metal chlorine bond is weak bond. Metal chlorine bond weak bond compared to metal carbon bond. So if you are using R is equal to methyl group, R is equal to methyl group, methyl magnesium halide, these two chlorines are replaced by methyl group. Cp2Ti methyl. I am using CH3MgX or CH3Li. Okay. Then what happens? Then in the next, so this is called the Petasis reagent. What is the active form of Petasis reagent? Cp2Ti double bond CH2. Popularly this one. This is the active form of Petasis reagent. Okay. Then this is Petasis reagent. Then in the next step, with the tetrahydrofuran, I am heating with the tetrahydrofuran for about 50 to 60 degrees Celsius. What happens is CH3 can be written as CH2H. Then elimination takes place. This hydrogen will make a double bond here. The CH3 is eliminated as CH3 and CH4 is eliminated, so that Cp2Ti double bond CH2. So alpha elimination, this is alpha hydrogen elimination. Alpha, with respect to metal, this is alpha carbon. Alpha hydrogen elimination takes place. Okay, alpha hydrogen is eliminated, so converted into the active form. Clear? Then write a question. A standard worked out example related to the Petasis reagent. Please write the question. Six-membered ring, double bond O, nitrogen, double bond O. This is NMe on reaction with Cp. Petasis reagent is not directly given. Instead of, the condition for the formation is given. Methyl magnesium bromide, then THF thermal condition. What is this? Cp2TiCl2, methyl magnesium bromide, THF 100 degrees Celsius. After all these steps, the active catalyst Cp2Ti double bond CH2 will be formed. Cp2Ti double bond CH2 will be formed. What is the functionality? Amide. RCONR2. Amide, two amides are there. This is amide, this is also amide. Reaction same, cut and paste. So how you can write the product? Six-membered ring. Here double bond CH2. Here there is an NMe. Then here also double bond CH2. Both amide will be converted into alkene. Both amide will be converted into alkene. Okay, double bond CH2. So this reagent is the condition for the formation of Petasis reagent. Preparation, first step, 2 chlorine replaced by 2 methyl group. If you are using methyl magnesium bromide, 2 methyl group. Or if you are using ethyl magnesium bromide, 2 ethyl group. Then alpha elimination. Hydrogen eliminated, 1 methyl group also eliminated, and alkane will be eliminated, so that your product will be this one. Okay, then write the next question. Write the next question. Double bond O is a cyclic ester or lactone. Okay. One reaction with a very interesting question. Ti, here Cp, and a cyclopropane system. Then 50 degree Celsius with tetrahydrofuran, THF solvent. What will be the reaction? See, instead of Cp2TiMe, normal Petasis catalyst is Cp titanium Cp 2 methyl group. 2-methyl group. Okay, so instead of 2-methyl group, 2-cyclopropyl group, then THF under 50 degrees Celsius is given. What happens? It is converted into the active form. Alpha elimination. With respect to metal, this is the alpha position. Here a hydrogen is there. That hydrogen will make a double bond. This group is eliminated so that it is converted into the active form Cp2Ti double bond cyclopropane system. So this will be your active catalyst. Clear? This will be your active catalyst. What happens in the next step? Same. It's a carbonyl group, cut and paste. Cut. So your product will be oxygen, Schmemberger ring, here double bond cyclopropane system. Instead of CH2, here cyclopropane system. So that's all about Tebbe's reagent, then Grubbs and Petase. So you can expect a question in this area. So our today's discussion about Schork carbene. Then the basis of Schork carbene, we discussed about what are the aspects Schork carbene, and then metathesis, then 3 important reagent. Okay, so practice previous question. If you are preparing only these lectures, that you will get only the theoretical knowledge. Practicing previous question, then only you will be more thoroughly, you can study the concept. Okay, so practicing previous question of TOEFL exam, NET exam, GATE exam, SET exam, then you will get a confidence. Okay, so wishing you all the best. Bye.